Alright guys, this is day 2 for Algebra 2 3.2.5. We're going to do a quick little wrap up of what we've been going over. So problem 111, we're going to be taking a look at the functions 1 over x minus 2 and 1 over x plus 1. So you're going to want a copy of Desmos out to do this, and then some paper to kind of do a little bit of kind of algebraic stuff as well. So first of all, we're going to be multiplying those and then writing out what we get after we multiply, and then graphing that and seeing, hey, does that match just saying f times g? And then do the same thing for addition, subtraction, and division. Say, hey, do all of these graphs check? That's a nice way to kind of double check and say, hey, did I do this algebraic portion correctly? And you should get the same graph if you just write it before you do any of the actual addition or subtraction. Same way, that should look the same before you do it and after you do it there. So go ahead and try that out and then come back here. All right, so if I pull up my Desmos, here we go. So here's those two original graphs. So if I write these so that they're being multiplied, so if I take this graph times this graph, right, I end up getting this blue graph here, right? And if we write it as one singular graph, right, it's just going to be 1 over, that would be x to the second, minus 2x plus 1x, so minus x minus 2, and we get the exact same graph, right? So not a huge deal. That's effectively what we're doing here. So then if we change this to being stuff like addition, right, I would write it as this plus this. That's the graph that I should get, right? And if I go ahead and go through the process of adding these up, multiply this one by x plus 1 over x plus 1, this one by x minus 2 over x minus 2, and then combine my like terms, I'll get the exact same graph. If I do it with subtraction, once again, you should get this graph here, and then it'll be very, very similar process as the one which we did for a addition. You'll combine those like terms, and you should see that exact same graph either way. And then finally, with division, I'll put this on the bottom. Here's the graph we should end up getting. So this one looks a little bit different because effectively all this is if we multiply by the reciprocal, this is going to be the same as x plus 1 over x minus, oops, put that in parentheses, over x minus 2. And those are the exact same graphs. Because again, all of this is take the bottom one and take this and multiply it by the reciprocal of the bottom, and that's what dividing by fractions does. So you fairly easily get the exact same result on that one. Okay, so with that, here's a little bit of notes again on these processes for adding in subtracting rationals. Again, we've gone over this the past few days. Hopefully you feel pretty good on that. Read through that and make sure you kind of understand what is going on there. And then for our closure here, we're going to talk about if this is a closed set or not, right? So if these rationals, if I added 2 rationals, did I get a rational? Yeah. If I subtracted rationals, did I get a rational? Yeah. If I multiplied, did I get a rational? Yeah, right? It may have been a rational with a bottom of a larger power, but that's still a rational, right? And then with division, I oftentimes, once again, got a rational there as well. So rational is going to be closed under everything, which is a fairly unique case for us. So 120 through 126, go ahead and do that as our final homework for 3.2.5 day 2, and then that is the end of chapter 3. So our closure for this chapter is going to be 127 through 136. And I will talk to you guys the next time.